LIFE CIPRIBER. The fundamental goal of the CIPRIBER project is to rehabilitate and conserve river habitats in an attempt to restore endemic native cyprinid populations in sites of community importance, SCIs, in the southwest of the province of Salamanca. Due to their limited distribution and current endangered status, these species constitute an enormously important genetic and natural heritage, and one that requires restoration and conservation through a package of measures and actions ranging from captive breeding to public education and participation programs. However, the primary goal of the CIPRIBER project is to improve river habitat conditions in the target area. Consequently, work has principally focused on eliminating environmental pressures in the rivers and rehabilitating river habitats and functions, and in particular, on restoring longitudinal connectivity throughout the entire river basin. This crucial feature is directly related to the free passage of fish species along rivers, which enables genetic exchange and strengthens populations. The area earmarked for LIFE CIPRIBER project actions is the southwest of the province of Salamanca, a region which hosts a variety of river systems ranging from large basins, such as the Agada River and its tributaries, to small temporary systems of enormous importance for the species targeted by the project. The first step of the project was to conduct an inventory of river obstacles in the area, which mainly consisted of disused weirs that hindered migration and genetic exchange between populations. This had led to the existence of numerous very small clusters of populations that were at risk of extinction due to their isolation. Therefore, one of the main habitat improvement actions implemented by CIPRIBER, and the one with the greatest impact on fish populations, has been to reduce these obstacles to the free passage of fish. The project has consisted of 2 stages: facilitating passage past 50 weirs in the project area and the total demolition of another 8, as well as the total demolition of the Llevadas Dam, one of the highest dams demolished to date in Europe. Although the most efficient solution to restore connectivity is the total demolition of obstacles, many are still subject to public service concessions, while the location and characteristics of others render demolition economically unviable. In these cases, partial demolition, together with the construction of fishways, is the best alternative to achieving the free passage of fish, although the design of such fishways requires careful planning and execution. The ramps designed for the CIPRIBER project optimized the concept of fish ladders. First, they have been constructed using natural materials. This avoids the introduction of new concrete structures in the rivers and has reduced the execution time and cost of the work, enabling the project to carry out a high number of such actions. Second, the design's technical characteristics render it feasible for a wide variety of river systems and facilitate the passage of fish both up and downstream throughout the entire migration season, which is essential if they are to complete their life cycle. Last but not least, the design generally has a low visual impact on the surrounding environment. These actions have been accompanied by work to improve lateral connectivity, which has included clearing vegetation and removing solid waste and fallen trees or logs, eliminating all elements that after completion of the works could reduce the effectiveness of the new fishways. Besides creating a passage past obstacles, the project has also demolished 8 weirs and the Llevadas Dam. The removal of this latter obstacle has made it possible to restore connectivity in a sector of the middle stretch of the Llevadas River, which is crucial for the migration of all these species. By completion of the project, the Llevadas River will be obstacle-free for 95% of its course. The length of the stretches improved by these actions depends on the characteristics of the corresponding river systems. Besides the Webra River, complete longitudinal connectivity will be restored throughout the length of the 23-kilometer-long Agaton River, the Peones Stream, the Gavilanes River and the Maillo River, and along 98% of the Rio Frio River. In addition, longitudinal connectivity above 90% will also be achieved in the Uces River as well as the Mores Verdes River, one of the temporary rivers with the highest diversity of species in the Duero Basin. By the end of 2019, the project's actions to overcome obstacles to the passage of fish will have restored contact between many of the previously isolated populations of these endemic Iberian species, facilitating their migration and therefore the genetic exchange needed to strengthen populations facing the challenge of climate change.